Lecture outline: numerical on continuous beam. Let's see numerical. Analyze the continuous beam loaded as shown in figure by moment distribution method and draw bending moment and shear force diagram. So in the given figure, different loadings are given. So AB span having a load of 8 kN acting at a distance of acting at 3 meter from A and 1 meter from B. Moment of inertia for span AB is 2I and span is 4 meter. Span BC loaded with the point load 10 kN at mid span, and span of BC is 3 meter and moment of inertia 3I. For span CD, load is 4 kN per meter UDL, span is 3 meter and moment of inertia 4I. B, C are continuous support and D is simply supported and A is fixed support. Now let first calculate fixed end moment. Sign convention: anticlockwise positive, clockwise negative. Now let first consider span AB. So fixed end moment at A in anticlockwise sense, so positive, WAB square by L square, because point load is not symmetrical, it is acting 3 meter from A and 1 meter from B. So A, let call A is equal to 3 and B is equal to 1. Total span is of 4 meter. So putting here, W is 8, A is, small a is 3, small b is 1 square, and L means span is 4 square. So is equal to 1.50 kN/meter. Anticlockwise, so moment is positive. Now fixed end moment for span AB at B, let call it as MFBA. So fixed end moment B for span AB is clockwise, so the sign will be minus. Now equation WA square B divided by L square, putting the value minus 8 into 3 square into 1 divided by 4 square, so is equal to minus 4.50 kN/meter. Now span BC. Now find out fixed end moment at B. For point load at center, equation is WL by 8. So fixed end moment at B is anticlockwise and fixed end moment at C is clockwise. So MFBC at B is positive and MFCB is negative. So loading is symmetrical, so equation remains same, WL by 8. W is 10, L total span is 3 divided by 8, so is equal to 3.75 kN/meter. For MFBC plus 3.75 kN/meter and for MFCB minus 3.75 kN/meter. Now last span CD loaded with 4 kN/meter UDL. So MFCD is equal to MFDC, because again the loading is symmetrical. So whatever the fixed end moment, the magnitude remains same. Only sign convention or their rotation is different one. Again, anti-clockwise we treat as positive and clockwise we treat as negative. Now equation for UDL is WL square 12. So W is 4, span is 3 and divided by 12. So 4 into 3 square divided by 12. The fixed moment is 3 kilonewton meter. Now next is distribution factor. Now find out distribution factor for internal joint. So for member, the internal joint is B and C. So write down first column of a joint, second is of a member. So in first column, first internal joint is B. Now member connecting to B, BA and BC. So BA and BC. Now next internal joint is C, and member connecting to C is CB and CD. So CD. Now find out relative stiffness for each member. First one, BA. So if this is my joint B, the far end of BA is A and this far end is fixed. So when far end is fixed, relative stiffness is equal to I upon L. Now I for span AB is 2I. So put the value 2I divided by 4. 4 is a span. Now next span BC. For span BC, C is a far end. Now far end is continue ahead. So relative stiffness is I upon L. When far end is continuous or far end is fixed, relative stiffness is equal to I upon L. So is equal to moment of inertia for BC is 3I. So 3I divided by 3. Now find out total relative stiffness. So 2I by 4 plus 3I by 3. So is equal to, by solving this, we are having a final value 3I upon 2. Now find out distribution factor for each span. So distribution factor is equal to relative stiffness of member divided by total relative stiffness. So span BA, relative stiffness is 2I divided by 4. So 2I divided by 4 divided by total relative stiffness, it is 3I by 2. So that become 2I by 4 into 2 upon 3I. So is equal to 0.333. Now next member BC. So distribution factor is equal to K divided by summation of K. K is 3I divided by 3 into 2 divided by 3I. But total relative stiffness is 3I by 2. So when we divide, it will become into 2 upon 3I. So is equal to 0.667. Distribution factor for PC. Now next member CP, total relative stiffness 3I divided by 3 divided by is 2I. So we are having 0.5 distribution factor. Now before that, let us consider joint C. This is joint C. Joint C. Now for joint C, first member connected is, first member is CB. So write down CB, member CB. Now B end is far end for joint C. B is a far end for the joint C. So far end is continuous, so relative stiffness is I upon L. I upon L. Now I is for this span is 3I. So 3I upon 3. Span is 3. Now for span CD, for joint is C and far end is D for CD. So far end is simply supported. So when your end is simply supported, relative stiffness is 3I divided by 4I. When far end is you are simply supported, it may be roller or hinge support or overhang. In that case, relative stiffness is 3I upon 4L. So 3 upon 4 into 4I divided by 3. For the moment of inertia is 4I. So putting that value, 4I divided by 3. Span is 3. So we having the relative stiffness 12I divided by 12. Okay. Now find out total relative stiffness for this joint. So addition of these two relative stiffness, 3I divided by 3 plus 12I divided by 12. So we having 2I. So total relative stiffness is 2I. Now find out distribution factor in same way for each member. So how to find out? K divided by total relative stiffness. So 3I divided by 3 into 1 upon 2I. So it become, distribution factor become 0.5 for CB. Now find out for CD, relative stiffness 12I divided by 12 into 1 upon 2I. So it become 0.5. So these are the value of distribution factor for each member. Okay. Now next step, draw the moment distribution table. So for moment distribution table, you first write down member, then joints. First is A joint, next one is a B joint, next is a C, and last one is your D joint. So for A joint, member is AB. For B joint, two members are there, BA and BC. For C joint, CB, CD, and for D joint, DC. Now in next row, write down distribution factor. As calculated earlier, distribution factor for BA is 0.333, BC 0.667, CB 0.5, for CD 0.5. No distribution factor for end. For end, A and D are the last end. No distribution factor for them. Now next one, write down fixed moment. For AB 1.5, BA minus 4.5, BC 3.75, CB minus 3.75, CD 3, and for DC minus 3. Now next step is balancing. So balance. Now AB is a fixed end. So balancing is not there. A is a fixed end because end moment will remain there. Now DC is a simply supported end. So your end moment should be equal to 0. But here fixed end moment is minus 3.0. So that means we have to make it 0. So to make it 0, you have to add balance moment plus 3. So we will get 0 end moment because the end is simply supported. When end is simply supported, the end moment remain 0. So that's why you have to make it balance. Okay. It may be roller or it may be hinge support. Your end moment remain 0. So to make it 0, you have to balance, you have to take opposite sign and same magnitude there. Okay, so it becomes 0 now. Now next step, half of it you have to carry at far end. So far end of D is C. So here you have to carry half. So half is 3 divided by 2. So plus 1.5. Okay, now balancing is completed. Balancing you have to do, you have to see end. If end is fixed, balancing is not required. If end is simply supported, you have to do the balancing. And half you have to carry at far end. Okay, so balancing is completed now. Then find out initial moment. So addition of fixed end moment plus balancing moment, you will get initial moment. So 1.5 plus 0 is equal to 1.50, minus 4.5 plus 0 is equal to minus 4.50, 3.75 plus 0 is equal to 3.75, minus 3.75 plus 0 is equal to minus 3.75, 3 plus 1.5 is equal to 4.5, minus 3 plus 3 is equal to 0. So these are the initial moment. Now look at intermediate joint. At intermediate joint P, to maintain the equilibrium, the addition of these two moments should be equal to 0. Then only equilibrium will be maintained. So whatever the moment coming from the adjacent span, their addition should be equal to 0. Then only the equilibrium will be maintained. So let's check. Minus 4.50 plus 3.75 is not equal to 0. So that value come out minus 0.75. So that means what? There is a need of a stability, and for that you have to make, or you have to add plus correction plus 0.75. So that correction you have to take plus 0.75. So that corrected value you have to correction moment you have to write down here plus 0.75. Okay, now let's check here for joint C. The moment CB is minus 3.75, moment CD is 4.5. Now add these together. Adding these two, we having moment plus 0.75 plus 0.75. That means what? It is not equal to 0. So you have to do the correction, and for correction you have to take corrected value minus 0.75. Okay, so that corrected moment you have to add, so minus 0.75. Okay, opposite side you have to take minus 0.75. Now next step, so correction moment is 0.75 into distribution factor 0.333, we will get distribution moment 0.250. Now find out distribution moment for BC. So this corrected moment or unbalanced moment 0.75 into distribution factor is equal to distribution moment 0.5. Now same way find out distribution moment for CB. Minus 0.75 into 0.5, it become minus 0.375. Minus 0.75 into 0.5 for CD, it become minus 0.375. So these are the distribution moment. Now next step is carryover moment. So carryover moment, now carry this moment at far end. So AB is a fixed support at A. So carry the moment at far end. So half carryover you have to take. So divided by 2. 0.250 divided by 2 become 0.125. Now carry the 0.5 at far end is C, half you have to carry plus 0.250. Now carry this distribution moment CB at far end B, half minus 0.188. Now distribution moment CD carry to the far end. Now far end is simply supported, so carry over is not there, 0. Now next is again distribution factor. Find out distribution factor. So unbalanced moment is minus 0.188 into distribution factor 0.667. It become 0.125. Now here minus sign is there, so you have to take positive sign because this is a moment. Okay, so after doing the carry over we having this moment. Okay, after doing the carry over we having this moment. So again you have to find out distribution factor. So once you having distribution factor, by doing simply multiplying this moment 0.188 to the distribution factor, you will get distribution moment. Only sign you have to take opposite to make it balance, because here is minus 0.188. If you take plus 0.188, then it becomes 0. So it made the your moment your joint equilibrium or maintain the equilibrium. So to take care of that, you have to take here opposite sign. If sign is minus, you have to take here positive sign. That care you have to take. Now next is carry moment is 0.250 into 0.5. Now positive sign you have to take minus 0.125. Again 0.250 here into 0.5. So you having minus 0.125. Now the next step is carry over moment. So half you have to carry at far end because far end is fixed. So half is 0.032. Again 0.125 you have to carry far end. Half is plus 0.063. Half again you have to carry at far end. CB moment is minus 0.125. Half is minus 0.063. No carry over for 0.125 because end is simply supported. Now after doing carry over, you have to find distribution moment. Distribution moment. So you are distribution moment you have to find out at the internal joint. So here internal moment is minus 0.063. So your balance moment you have to take plus 0.063. So that into this distribution factor we having distribution moment 0.021 and 0.042. Again here balance moment will be minus 0.063. So minus 0.063 into 0.5 we having minus 0.032. Again minus 0.063 into 0.5 we having minus 0.032. After doing this after this distribution you have to add initial moment all these moment from initial moment up to the distribution moment, all moment you have to add, you will get final moment. Okay, so find out final moment 1.50 plus 0.125 plus 0.032 we are having plus 1.657. The next one minus 4.50 plus 0.250 plus 0.063 plus 0.021 we are having minus 4.166. Again adding all these we are having 4.166. Next one minus 3.75, add all these moment we are having minus 3.969. Then 4.5 plus minus 0.375 minus 0.125 minus 0.032, we are having 3.969. Okay, so that means we balance our moment at the joint, internal joint. You see plus and minus sign is there and magnitude is same, so it automatically when you add you will get 0. So these are the final moment, okay, calculation. Next part we will resume in the next video. Okay, thank you.